Back then in secondary school, when we were asked to find the volume of a cone, all we just did was to cram and solve the question, including myself. So in this video, I'm going to be showing you how we got to derive the formula for a cone. And this formula is basically V equals to 1 over 3 pi r square h. Welcome back to this channel. This is Bam's Academy. And so if you are new to this channel, don't forget to click the subscribe button. So quickly, if I should have a graph, let me just quickly give you the analysis. If I have a graph, a linear graph, basically. So a linear graph mathematically is y equals to mx plus c, right? Then if I should take, let me bring this one down onto the x plane and the x-axis I mean. So if I should take the revolution of this particular straight line into angle of 360, it will look, it will swipe like this. That's what you can see here. So there will be a round stuff just like what you can see. All right, so now we have a shape that looks like a cone. Of course, this is a cone. So if I want to find the volume of this, what I just need to do is first I want to take note of another part of this cone, a smaller part indeed, and I take this. All right, so this here is is corresponding to all of the y's. What I'm saying is that from here, these are the changes in y. The y on the y part increases, right? So I'll call this my radius of the circle to be y. Now if I should bring out this circle that I just constructed, I will have something like this. All right, then with a radius r. Right, first we want to know that the area of a circle is what? Is pi radius square, and in this case our radius is r, so pi y square. All right, so if you should keep cutting this particular shape like this, keep cutting it gradually and gradually, we're going to have a shape that looks very, very interesting. We are going to have something like this. Then the back which I'm cutting will look more like a cylinder, and there is still the surface, right? The surface of r of y. Now if I should want to consider this particular shape, this is a cylinder, and for every little cut that I have, let me call it a change, right? I'll call it a change in x because I'm cutting it along x-axis. It's a change in x. So if I want to find the volume of this, because I want to find the value of the cone, right? So if I'm to find the volume of the cone, if I can get the volume of all of the small cylinders in the cone, then I should be able to get the volume of the entire cone. So I would say that for all of the small cones, small cylinders, the volume will be the volume of this cylinder here is basically pi y square h. Now the h here is the height, which is going to stand for delta x, right? So this is delta x. Is that okay? So now I've gotten the volume. This is the volume of the cylinder, which is one of the cylinders I can find with a small cut. If I should take capital V, that means the summation of all of these, V's, that is if I should take the summation of all of these guys that I have here, then I can have the entire V, which is the entire volume I'm looking for. Meanwhile, I cannot count the amount of cut I can have, because if I should say that there is a cut here, if I should zoom in, I can still have something very, very little in between here. So it's going to tend to infinity, right? So I will say as the change in x, that means the cutting, tends to infinity, what will happen? I can do a smoothing. That is, V will be a smoothing, that is integration from 0, because it started from 0 here, then to h. So this along this, right? It goes, and this is the height. So to h, what am I looking at? Then I will have pi of y squared. Then this little change will turn to dx. Now the basic thing we now want to focus on is to get what y is. Once we can get the value of y, then we are on our way to derive the formula for v. So recall that I said y is equals to mx plus c. Meanwhile, in this question, our c is going to be 0 because it's 0 intercept starting from the origin, right? So it's intercept 0. So I'm left with y equals to mx. Now, what exactly is my m? My m is gradients, right? So if I want to get that, it will be that m is equals to the change in y. Now all of my y is here. That means the change in all of this y here, y is increasing, the changes in the y, changes in the y, and alongside of this x as it's changing. So I would say m is basically my y. Now my y in this instance is actually my radius, right? So I've said the radius of all of these circles I would have gotten over the height. So that would be my m. So we can now conclude that my y basically will be rx over h following this. So I've gotten the value of my y. So let's put all of this together, then we can see what exactly we are trying to achieve. Now that we know that v is equal to the integral from 0 to h and pi, so we already know that y is rx over h, then to the power of 2 dx. Then this is exactly integral from 0 to h pi of r squared x squared over h squared, then dx. Okay, so what do? I will integrate with respect to s, and that's going to give me v is equal to pi r squared x to the power of 3 over 3h squared, starting from 0 to h. So let's plug in our values. So I'll put the upper bound, which is pi r squared h cubed over 3h squared minus, if I should plug in 0, that's still going to be 0. Cancel out all of these ones. We are going to have this having just one h left. You see that we've gotten the answer. So v will be equal to 1 over 3 pi r square h. And that's it. Very, very easy and simple. So when else you ask, how do we get the value? How do we get the volume of a cone? This is how we get it done. So don't forget to like, share, and subscribe to this channel. And until then, I will see you in the next video. Bye for now.